All right, in this video, we're going to look at radical functions. I'm going to show you what the parent function is for a radical function, and then how to transform and translate that function, and then how to find the domain range in both the x and y intercept. All right, so the first thing we need to talk about is the square parent function f of x equals square root of x, right? So if I just make a quick list of values, x and y, I can start to see that if I plug 0 in for x, I end up getting 0, so I get 0, 0, so that's 1 point. If I plug in a 1, I got square root of 1, which is 1, so I get that point right there. And then the same thing, if I plug in a 2, I don't really want to do that one because square root of 2 is a decimal, so I don't want to mess with that. So I'll plug 4 in there. Square root of 4 is 2, so I got 1, 2, 3, 4, 2. To plot in there. So you can see that the parent function of a radical function is this curve over to the right there, okay? So what I'm going to do now is I'm going to leave that parent function there so we've got something to compare it to. And then we're going to take our new function and we're going to translate it according to what we have on our function here. So we have this function here. I'm going to rewrite it a little bit so it makes it a little easier to notice. So I have f of x equals -3 square root of x plus 4, and then I'm going to put the plus 1 in the very back. Okay. Now then, if we remember, when we're talking about parabolas, if we had x squared plus 1 or x squared minus 3, that just tells me an up and down shift. So this plus 1 right here tells me up or down shift. Okay. So this tells me shift up or down. In this case, I'm going to go up 1. Okay, and then this 4 right here, this is underneath the radical. Okay, so that 4 is going to tell me to shift right or left. And remember, if we had x minus 2 squared, that would tell me a right shift. Don't forget, if it's inside parentheses or inside the square root, it's going to be opposite of what we think. So now what we have here is my normal spot is to start at 0, 0 for my parent function. But from my original 0, 0 beginning in my parent function, I'm going to go up 1 and left 4. So let's do that. I'm going to go up 1 and then left 1, 2, 3, 4. So there is my new spot there. Okay. Then the other thing to notice is I've got this -3 right here, right? If I had negative x squared, it tell you what. Remember what it does to my parabola is it flips it and points it down. So I'm going to have a similar shape right here. And I'm going to make this a dotted line, right? It's going to look something like that. But then this 3 right here is also going to stretch it vertically. So I don't know exactly where it's at yet, but I do know that it stretches it by 3. Okay, and there's two ways you can go about handling this. You can understand it stretch it by 3. So I take my normal y movement and then multiply it by 3. Or a quick, easy way to do it is to just say, you know what, I'm going to make a quick table of values over here. I got x and y. So I'm going to choose numbers over here that help me with my radical. For example, if I plug in a 0 right there for my x value, -3, 0 plus 4 plus 1, right? And let's do some quick math here. I have 0 plus 4 is 4. Square root of 4 is 2. Times -3 is -6. Plus 1 is -5. So all I did, I know I did that fast, but I plugged in a 0 right here and then evaluated this all the way to get that next number. Okay? So now I'm going to erase that. I'm going to try a different number. I'm going to choose a number that's going to give me a nice square root so that even square root so that I can get whole numbers here. For example, if I'm going to choose another one, I'm going to choose 5 here, and you'll see why here in a second. Now I'm going to plug it in here. I have -3, 5 plus 4 plus 1. So now inside my radical, 5 plus 4 is 9. Square root of that is 3. 3 times -3 is -9. Plus 1 is -8. So now what I have is -5, -8. And you can keep on going and you can pick different numbers that will help you there figure out where we're going to be. But as you can see, our graph here is gonna get off of the grid line. So what I'm going to do now is I'm going to go plot the few points that I do have, or try at least. The only one that I can point is 0, -5. So now I know my graph is going to look something like that. Okay, so now let's go over here and talk about what the domain range x and y intercept are going to be. So domain, if you remember, is all of my x values. So I'm going to go ahead and erase our parent function. So if you'll notice, the furthest I can go to the left is right here at that -4. So my domain is going to be -4, but my x has to be bigger than or equal to -4. And you'll notice this arrow right here means I continue going on to the right forever. So my domain is any number that is bigger than or equal to -4. All right, so now if I look at my range, the highest that this thing goes is to 1. So I know, and then everything is below that 1. So I know my y is going to be less than or equal to +1. Because this arrow, even though it is going more predominantly right, it will continue to go down and down and down forever. All right, so then the next thing we're going to figure out is the x-intercept. What do we know about the x-intercept? Well, I know my y would be 0. So what I can do is I can take my original function. All right, I got y equals 1 minus 3 times the square root of x plus 4. Plug in a 0. And now what we have here is a radical equation. So I'm going to solve that radical equation. I got -1 equals -3. Square root of x plus 4 divided by -3. That is 1 positive, now 1/3. I got x plus 4, and then I square both sides to make sure that radical goes. I got 1/9, and then I got x plus 4, and then I got -4. So I got 1/9 minus 4, but watch how I'm going to do this. I'm going to go -36/9, right? Because 36 divided by 9 is 4. And now I got common denominators, so now my x-intercept, my x value here is going to be -35/9. Now you could go ahead and get a decimal value for that, or leave it as a fraction. It doesn't matter. Okay, then I'm going to erase that. Now we're going to go find the y-intercept. And that is going to, I know for my y-intercept, I have an x value of 0. So I take my original and plug it in. So I got -3 square root of 0 plus 4 plus 1. So I have -3 square root of 4 is 2. -6 plus 1, and that comes back to -5. We now found the domain, the range, the x-intercept, and the y-intercept. Okay, and all we did was we shifted our parent function of square root of x. All right, now here is another one. Try this one on your own. Pause the video. We'll come back and we'll do it real fast. All right, now that you had a chance to practice this one on your own, this one's kind of tricky. If you ever run into something that's really tricky and you can't quite figure out how to shift it, move it, or rotate it, your best bet is to always just create a table of values, start plugging in numbers to x, find you a good set of values to plot, and then you'll start to get an idea of what your graph looks like. Then you can figure out what those shifts and rotations are. So if you ever find yourself trying to answer a question as to how that thing shifts, uh, just graph it. Get you a set of values. Just pick random numbers for x. Pick the ones that work. If you end up picking x value that gives you a decimal, go pick you another one, right? Be smart, be clever about how you can get perfect squares inside of here. That way you can get whole numbers when you fill in that table. All right, so let's look at how to do it if we just look at it from the equation. Now the tricky thing about this is I want the number in front of that x to be a 1. Okay, I want that to be an invisible 1. So in order to do that, I have to factor out a 4. So now I have the square root of -4, and I got x minus 1 right here. Okay, and so now then we'll see how that plays out here in a second. But what I know now is I go up 3 and then right 1. So let's go up 3 and right 1. 1, 2, 3, right 1. So now I have this one right here. And now I know this -4 right here, right? I know the normally, right? Normally our graph looks like this, okay? And then normally what we have is a negative on the outside of our square root sign, which would make our square root go down. So what we have is a negative on the inside, which is going to make our square root curve open up to the left, okay? And again, I don't know how this 4 is going to stretch it vertically or horizontally, right? Maybe I've forgotten, but it is going to affect it horizontally. So let's just make a table of values so I can figure out what's happening. Now, if I'm clever, right, I'll realize, hey, if I plug a 0 in there, that turns into 0. which leaves this as being a 4, which, hey, that's a perfect square. So let's plug that in. So I have 3 plus square root of negative 4 times 0 plus 4. Let's just evaluate that thing out. So we have negative 4 times 0, which is 0, plus 4, which is square root of 4, which is 2, which is plus 3, which is 5. So if I plug in a 0 there, I get 5. So I have 0, 1, 2, 3, 4, 5. There we go. So I'm going to plot that point there. So now let's see what happens when I plug in a 2, right? Let's erase this other one. Let's put a 2 in there. So I got negative 4 times 2. Well, negative 4 times 2 is negative 8. Negative 8 plus 4 is negative 4. So now you can start to see what we get. Oh, we're starting to get negative numbers. I can't have the square root of a negative value, so that's going to leave me with something that's imaginary or complex. So I don't want to use the 2, right? Again, I just tried something. Didn't work. That's all right. I'm just going to erase it and try again. So now instead of a positive 2, let's try negative 2. So I got negative 4 times negative 2, which would give me positive 8 plus 4 is the square root of 12. Square root of 12, that's not a whole number, so I don't want to use that one. So now what if I use a negative 3? So I got negative 4 times negative 3, which is positive 12 plus 4. Well, that's 16. Square root of 16 is 4. 4 plus 3 is 7. So now what we can do is we can go negative 3, 1, 2, 3, 1, 2, 3, 4, 5, 6. And here I'm starting to go off my graph, so I'm going to stop plotting stop getting points from there. But I can start to see I have this square root that opens up over here to the left side. Okay, and I'm going to erase that so I got some room to do a little side work. My domain is the farthest to the right that I go would be 1, so I know all of my x values are going to be smaller or equal to 1. My range values, I know the smallest value I have right there is a 3. I want to be bigger than that, so I want to say y is greater than or equal to 3. Now my x-intercept, if I look at my graph, I can realize, well, hey, this thing's never going to touch the x-axis. So I can say no x-intercept. And then if I think to myself here, okay, if I look here and I got my y-intercept, we've already got that plotted, then that's at 5. I could say my y-intercept is at 0, 5. All right, I hope that video helps. Remember, if you ever get confused about the translation or how to shift a function, make a table of values. Just start plugging numbers until you get enough of them that you can plot so you can get a good idea of what's going on with that function. Hope this video helps, and I'll see you in the next one.